Welcome to the second part of the HTML5 Advanced Theory course. Now, it's a fact that each and every HTML element can be seen as a set of imaginary rectangles encased within each other, and this is known as the CSS box model. The content can be some piece of text, image or video. It is contained inside a padding rectangle, which in turn is contained in the border rectangle. Through CSS you can set different kinds of fancy borders and change the background color of all of the aforementioned elements. The function of the abstract margin rectangle is to distance the element from the ones that surround it. Therefore, its background color can only be transparent. It's important to highlight that when calculating the distance between the borders of two elements, the size of the margin of both elements must be taken into account. I'm about to show you another example. Let's go for something slightly different. First of all, let's get rid of the CSS code. Div hello world. Hello world again. Body, font size 15 pixels. Div background color white. Margin 10 pixels, 50 pixels, 100 pixels, 200 pixels. Remember, it's a clockwise rotation. This means this one is the top margin, this one is the right margin, bottom margin, left margin. Clockwise rotation. Border 10 pixels solid red. I wrote the number of pixels only once. This means that the size of the margin for every side of the rectangle is 10 pixels. Padding 100 pixels, 0 pixels, 50 pixels, 0 pixels. Text align center. Alright, so what does it mean that the size of the margin of both elements must be taken into account when calculating the distance between the borders of the two elements? You see that both of these elements have 100 pixels bottom margin and a 10 pixels top margin. 10 pixels, it means that the distance between the boundary of the page and the margin, the border is of 10 pixels. This is a 10 pixels space, and the cumulative distance between this one margin and this other one margin is the bottom margin of the first one, 100 pixels, plus the top margin of this one, which is basically the same as the other one, 10 pixels. The distance is 100 plus 10, 110 pixels. It doesn't get easier. You may have noticed that I've only spoken about pixels so far, but in fact there's more. There are several units of measurement available for both font sizes and the spatial distances. Let's begin with the fonts. Well, pixels or absolute size is kind of self-explanatory. On the other hand, EM means that the size is relative to the parents. The size of the font of the element is going to be, for instance, the size of the font of its parent multiplied by 1.5. And REM means that the size of the font of the element is going to be the size of the HTML element, the root element, multiplied by 1.2, for instance. The constant immutable size of the root font, 1 rem, is always equals to 16 pixels. Later on, I'll cover a situation in which the rem unit should be used. There are also some dedicated units of measurement used when dealing with spatial distances, like width and margins. First of all, the absolute size. It's the same as for fonts. Secondly, the relative percentage. It is a reference to the size of the attribute of the element's parent. For example, the width of this one square might be 30% of the width of its parent element, the green rectangle. Then we have the viewport height and width. They work like percentages, but they refer to the size of the rectangle of the browser in which the page is shown in pixels. That is known as the viewport. They are particularly useful with margins. In some way, a comparison can be drawn between em and percent, and between rem and vw or vh. They respectively make use of local and global references. Now let's see them in action. Alright, so let me write this. Div world hello. Yeah, it is contained inside the hello world div element. And now font size 3em. Yeah, in the beginning I set the default size of 15 pixels for all elements. Now, as you see, the size of the world hello text is 3 times the size of its parent, and 3 times 15 equals 45 pixels. Yeah, this text is 45 pixels tall. Yeah, I could not expect a different outcome than this one. Needless to say, if your task is to nest multiple elements of the same type, to, for instance, create an element that contains multiple copies of itself, then using em as a unit of measurement is not a wise choice at all. But if I write 3 rem, then the size of all the div elements is surely going to be the same. And the same goes for margins. If I write 20% and 20% here, then this distance is going to be 20% of the width of the viewport from here to here, and this distance is going to be 20% of the width of the parent element, and this distance is not equal to this one. But if I write 20 viewport width and then 20 viewport width again, then this margin and this other one margin are definitely going to be the same, because they are both references to the width of the viewport. The two margins make up exactly 40% of the width of our window. Now behold, this is probably the single most important piece of knowledge in the CSS universe. Once you've gained mastery of the display property, then it's going to be downhill all the way for you. The display property, along with the position property, affects the displacement of the elements in your page. we'll finally get the distinction between a block element and an inline element. But first, take a hard look. The one in blue is the baseline the text is cleaved, attached to, and you won't get the chance to see another one. Why? Because it is never drawn by the browser, nor exposed to the developer through inspection of any sort. Every box, every element can have its own baseline. Yeah, this is an inline element. Why? Because an inline element doesn't drop to the next line, it appears to the right of the preceding inline neighbor. The width is simply the width of the content plus any padding. It ignores the top and bottom margin settings and ignores width and the height as well. It is subject to the vertical alignment property. We'll see later on how. It supports padding, but it does not contribute to calculation of the baseline. It cleaves to the baseline, yeah. Well, what if the element has a baseline of its own? This means that it is a block element. A block element appears below and to the left of block level neighbors. It's like a sort of a carriage return, you know, if you press enter in a text editor like Microsoft Word. A block element will expand to fill the width of the parent container by default. It respects all the margin properties, top, bottom, left, right. You can set its width property to make it narrower, so it does not expand to fill all the available width. You can also set the height. If unset, it is the aggregate height of all its children. It also ignores the vertical alignment property, unlike an inline element. And there is also a middle ground, a compromise, an inline block element. They are kind of the same as inline elements, but they have some features that normally belong to block elements. They respect the top and bottom margins and the size properties, the width and height. The vertical padding this time contributes to the calculation of the height. And yeah, these are lists of common elements in HTML whose default display property are block, inline, and inline block respectively. You see that by default paragraph, div, a block quote, a title h1, they're all block elements, whereas bold, italic, a link, a span, they're all inline elements, they don't drop to the next line. Images, buttons are inline block elements, and you can set the display property in this simple way. The CSS attribute is known as display. Right. Hello guys, it's me, the Almighty One, who cannot be replaced by anyone else. Am I right? This is in another paragraph. And now P, background color yellow, padding 50 pixels, bold and italic elements, font size 2em, background color light blue, margin 20 pixels, padding 10 pixels, no, 100 pixels, 30 pixels, 100 pixels again, 30 pixels again. Width 100 pixels. Alright, time for a few considerations. First and foremost, the 20 pixels margin can be seen only by the left and the right sides of these inline elements. That's because the elements are inline by default, therefore the top and bottom margins cannot be set. And for the same reason, it's not the width or height property that altered the size of these elements, but the padding. When I said that the padding does not contribute to the calculation of the baseline, in a nutshell it means that the text stands still while the padding box grows in size, to the point that it can overlap with other elements that surround it, like the paragraph, am I right? But if I change the display property to block, then the width property starts making sense. If it was left unset like this, the element would behave like the yellow paragraph and fill up the whole screen. That doesn't happen simply because of the margin. Also, you see that both elements dropped to the next line and now are cleaved to separate baselines. If I set them to inline again, and try writing height 500 pixels, of course it won't work because width didn't work either. But if I set them to inline block, the paragraph will grow in size to fit the inline block elements, because this time their width can be set and their height can be set as well, and margins and paddings are taken into account when calculating the size. Now I can also change the vertical align property to top, for instance. You see? In doing so, I affected the behavior of the entire baseline. Here's another useful tip for you. It's about the horizontal centering of an element. If the element happens to have an inline or inline block value of the display property, then you must set the text align property of its parent to center. You see? On the other hand, if it's a block element, you must first resize the item, otherwise it would use the whole screen as we've seen before. And then you must set the margin property to auto. This is the way this pink block container has been centered in the screen. Finally, the last property we're going to inspect in this course is the position. There are 5 different types of positioning of an element inside its parent or the viewport. The first one is the static positioning. It's the default for all elements. Take a look at the search bar. What happens if you use the scrolling wheel of your mouse when you're in this window? When you scroll down, the statically positioned element moves with the flow, and you no longer see it until you return to the previous position by scrolling up. But that's not the case if the element has a fixed position. You see? The element has a fixed position in the viewport. No matter how much you scroll down, the element will firmly stay there. Fixed positioned elements neither contribute to the size of the parent, nor get the width of their parent. Opposite properties can be used to size an element, and these properties are left and right top and bottom. Be careful, because these exact keywords do not make sense when applied to every other property. It is a common error to try to move a static positioned element with these properties in vain instead of using the margins and padding properties. And then there's the relative positioning. Take a look at this blue round icon. You see that there's definitely something wrong. This is the original position of the element, or rather, this would be the original position if the relative positioning wasn't set. The relative positioning allows the creation of an offset from the original position of an item. The four positioning properties will move the named edge of the element from its initial position by force. The position of the rest of the elements won't be altered. The properties are left, right, top and bottom. Items are positioned independently of their siblings, and opposite positioning properties like left and right cannot be used simultaneously. This means that you can't first set a 70 pixels offset from the left and then a 50 pixels offset from the right. You must do one thing at a time. In this case, the positioning is relative. The left offset is by 20 pixels and the top offset is by 10 pixels. Then we have the absolute positioning. It's kinda similar to the fixed positioning in many aspects. Take a look at this sign. First it's here in the top left corner, and then it's here in the top right corner. How come? The behavior is the same as in fixed positioning, but it is not relative to the viewport. It is relative to the most immediate ancestor, whose position is not static. And if there is no positioned ancestor, the element will behave as if its position was fixed. We first set to the huge container rectangle a relative position. Then we set an absolute position with a 0 pixels right and top offsets to this small sign. Then we have the sticky positioning. It is the last kind of positioning we're going to see. You simply have to read this sign in the yellow background. I will stick to the screen when you reach my scroll position. What happens when you scroll down? The position is reached and the element sticks to the screen. The sticky positioning is similar to relative positioning, but the offset is computed with reference to the nearest ancestor with a scrolling box, or the viewport if no ancestor has a scrolling box. Once the element reaches a fixed scroll position, which is set through the 4 positioning properties, it stands there even if you keep scrolling. And this technique is frequently employed with navigation bars. In this case, the position of this element with the yellow background is sticky, and the offset is simply top 0 pixels. Left and right instead are available when you deal with horizontal scroll bars. That's not the case because in this example we have a vertical scroll bar. For almost each CSS attribute of an element, you can easily choose to make it inherit its parent value of said attribute. For example, you can write a paragraph display property inherit from its parent element. And then we have the CSS layout tips and practices. Let's begin with the foundations. First of all, you have to separate content and style. Do not use tables for layout as many did back in the day. Maintain a logical source order. The page should make sense even without a CSS file. Learn how to use CSS before relying on frameworks like Bootstrap. The testing part. Fourth rule, test the page without CSS. Test it in multiple environments, even with multiple devices. Resize the window, zoom the text, try a mobile browser. Test in multiple browsers as well. Adaptability. Seventh rule, use liquid layouts. Avoid the absolute units pixels. Use yen for font size. Use percent and or viewport units for block sizes. Avoid absolute units for images and videos as well. Then we have the coding part. Use exclamation mark important with caution. Do not use it for easy fix-ups. Ninth rule, do not over-escalate. This is a particularly bad example of over-escalation. Position absolute left 1 million pixels. Do not do it. Then do not keep dead or zombie code in your page. That does not work. And finally, do not use proprietary features like Microsoft, Mozilla or WebKit CSS extensions. Or rather, if you can, you should avoid them. This is work by myself, Francesco Ceccato. This is the harvest of long effort and commitment which have spanned several weeks. It is a huge yet organic collage which can't be further broken down in single units or weeks, because the order of the content on display is significantly different from that in the original source. Nevertheless, I still deem the content relevant, because chances are some part of it will be neglected during the ordinary computer science lessons.